everyone. For today's lesson, we are going to learn about the properties of of squares. For today's lesson, you will want to have some colors with you. You will want to have a calculator for some of the calculations, and you'll want to have something to write with. I also strongly recommend that before you watch this video lesson, please make sure that you have completed our vocab video lesson that discusses the properties of squares. So let's go ahead and recap our properties of squares. Now remember that squares are not just a parallelogram. It is also a rectangle and a rhombus. So that means that a square has all of the properties that we have talked about so far. It has the form a parallelogram, opposite sides are parallel, opposite sides are congruent, opposite angles are congruent. There are four consecutive interior angles are supplementary, and the diagonals bisect each other. All of these properties are true, and they came from parallelograms. The extra properties that they got was that a square has four right angles, and they got that property from rectangles. So there's four right angles. And as a consequence of having four right angles, that means that the diagonals are congruent. So from rectangles, we have diagonals being congruent and four right angles. But a square is also a rhombus in the fact that it has four sides that are congruent. So all sides are congruent. And as a consequence of all sides being congruent, the diagonals bisect the opposite angles. So if we know that each of the angles is 90 degrees, half of 90 is 45. So we have ourselves 45-degree angles. And the diagonals are perpendicular, so they intersect to form right angles. So that is one of the really cool things about squares, is that it has all of the properties that we've talked about. So you have to remember all of those properties to help you answer some of these questions. All right, let's go ahead and look at example number 1. Now, for these types of problems, you always want to pay attention to what shape they're giving you, because it's just going to be nonchalantly written in the example. It says the diagonals of a square. So we are referring to a square. I know that a square has all sides that are congruent. It has four right angles. So I'm going to mark that up. We have ourselves diagonals that are perpendicular. And we have diagonals that are congruent. So I'm going to mark all of that up on my picture to start this problem. We are told that G to J is 15, and we want to find the indicated measure. So first we're going to find the measure of angle EJF. So EJF, we already marked that up with a right angle. So EJF is equal to 90 degrees. Next, we want to find the measure of angle JFG. So here's JFG. And one of the things that I need you guys to know about angle JFG is that the diagonals bisect the opposite angles. So if that's the case, half of 90 is 45 degrees. So therefore, we have a 45-degree angle right here, because that's the property that we're using, that the diagonals bisect the opposite angles. Next, we need to find what F to H is. So we know that the diagonals are congruent, and if this piece is 15, this other piece is 15, this piece is 15, and this piece is 15, because the diagonals are congruent and they bisect each other. So therefore, the length of F to H, which is this whole diagonal right here, is 15 plus 15, and 15 plus 15 is 30. And finally, we want to find what E to J is, and that is, once again, 15. Next, we're going to go ahead and look at LMNP. We are told that it is a square, and we have information about the angles, and we know that all of the angles of a square are right angles. So we're going to say that 8x plus 26 is equal to 90 degrees. I'm going to subtract 26 on both sides, and when I do that, I end up with 8x is equal to This one's going to be 64, dividing both sides by 8. We find that x is equal to 8. All we needed to do. Next, let's look at example 3. Now, this is where it gets tricky. It's all about what is marked. We want to decide whether the shape, this is a parallel, or whether the parallelogram is a rhombus, rectangle, or square. So it's not about what it looks like, but it's about the information that is marked. So in this problem, letter A, I can see that we have 4 right angles and opposite sides are congruent, but all sides are not congruent. Therefore, the most specific name that I can give is a rectangle. Next, letter B. Letter B looks like a square, but the right angles are not marked. So therefore, we have to go with the most specific that we can actually say, and this makes this a rhombus. Even though it looks like a square, we do not know for a fact that the angles are right angles. Letter C is the same exact story. We have 4 sides that are congruent and we have no information about the angles. Therefore, we can only conclude that letter C is a rhombus. And finally, we do know that all sides are congruent. We know that all 4 angles are right angles. Therefore, the most specific name that we can give is that this shape is a square. So it's all about what information that you see, not what you can assume. So always assume that if it's not given, you cannot conclude anything yet. Let's go ahead and look at example number 4. We are asked to classify, so that means give it the most specific name. Classify the quadrilateral, then find the values of x and y. So what I see in this problem is I see 4 sides that are congruent, and one of the angles is 97 degrees. That's not a right angle, so therefore this means that this is a rhombus. And so it'll follow all of the properties of a rhombus. We know that one of the properties of a rhombus is that all of the sides are congruent. So if one side is 5x plus 6 and another side is 8x, I can set 5x plus 6 equal to 8x and I can solve for x. I'll subtract 5 on both sides. I'll end up with 6 is equal to 3x. Divide both sides by 3 and I'll find that x is equal to 2. Next, I know that the angles inside, I know opposite angles are congruent, but the angles that touch each other, like P and Q, these are consecutive interior angles and they are supplementary. So I'm going to add 12y minus 1 and 97 together, and I'm going to set it equal to 180 degrees because these angles are consecutive interior. Please be careful. A lot of kids will get this one incorrect because they'll set the angles equal to each other because there's so many opportunities where we set pieces equal to each other, but you have to be really, really careful and remember what you're talking about. So I'm going to combine my like terms, and I end up with 12y plus 96 is equal to 180. I'm going to subtract 96 on both sides, and I end up with 12y is equal to, I believe this is 84, but let me confirm. Yes, 84. I'm going to divide both sides by 12, and I find that y is equal to 7. So those are my 2 answers. Let's go ahead and look at letter B. For letter B, I can see that I have 4 right angles, but I don't know any other information. So therefore, I'm going to conclude that this is a rectangle, indicating that opposite sides are congruent. And if that's the case, I'm going to set 5x minus 6 equal to 4x plus 7. And then eventually I'm going to set y plus 3 equal to 2y plus 1. And I'm using that property that opposite sides are congruent once again. So I'm going to subtract 4x on both sides, and I'm going to add 6 on both sides. And when I do that, I end up with x is equal to 13. Next, I'm going to set my opposite sides congruent to each other. So therefore, I'm going to set them equal to each other. And I have y plus 3 is equal to 2y plus 1. I'm going to subtract y on both sides and subtract 1 on both sides. And when I do that, I end up with 2 is equal to y. And I have officially found my missing variables. Let's go ahead and flip the page. The next two problems are you tries. So I would like you guys to please go ahead and try these problems on your own and then have a conversation with me when you see me in class. We can talk about those. And we have one more example to talk about. And this one is really important. A lot of kids really struggle with this idea of what's congruent versus what is not congruent. So I want to make sure that I talk to you guys about that. All right, so determine if the statement is true or false. So remember that in this chart, this quadrilateral chart, whenever you have shapes that are connected to each other, like going down the chart, the answer is sometimes. And if you're going up the chart and there's a connection, then the answer is always. If there's no disconnect, like no connection, meaning like there's no connective line truly between parallelogram and a kite and a parallelogram and trapezoids, then those would be never. So no connection is never. So that is something that I want you guys to know. So once again, all of our shapes that we have in our quadrilateral chart is we have a quadrilateral at the top. Quadrilateral, once again, is simply a four-sided figure where all of the angles add to 360. Every shape that comes after that they have those properties. They're all four-sided figures and all of the angles add to equal 360 degrees. Our focus has been on the center so far. We have parallelogram, and a parallelogram has opposite sides that are congruent, opposite sides that are parallel. We have opposite angles that are congruent, and we have consecutive interior angles that are supplementary. And then we have diagonals that bisect each other. And that is true about a parallelogram. Parallelograms are connected to rectangles. Rectangles, we know that the opposite sides are congruent. We know that they have opposite sides that are parallel. We know that the angles are 4 right angles. Let me write down that this is a rectangle. And we know that the diagonals bisect each other, but more specifically, the diagonals are congruent. This shape over here is a rhombus. We know that a rhombus has all sides that are congruent. We know that in a rhombus, opposite sides are parallel. Oh, I'm sorry, over here, I forgot to mention that we have consecutive angles are supplementary, so I forgot to mark that up. So we have opposite sides that are parallel. We know that most of the time are not right angles, so I'm just going to mark that simply opposite angles are congruent. And we know that the diagonals are not congruent, but the diagonals bisect the opposite angles. And we know that, so I'm going to mark up that the diagonals are not congruent, but what's really special about them is that they intersect to form a right angle. We do have consecutive interior angles that are supplementary as well. So I'm going to mark that up. And finally, we have a square. The square has all of the properties that came before. It has that opposite sides are congruent, but more specifically, all sides are congruent. Opposite sides are parallel, so I'm going to mark that up because it's a parallelogram. We know that it has 4 right angles because it's connected to a rectangle. We know that the consecutive interior angles are supplementary. 90 plus 90 is 180. We know that the diagonals bisect each other, but more specifically, they are congruent and they intersect to form right angles. Finally, we know that for these two, that the diagonals bisect the opposite angles. So I'm going to make sure that I mention that as well. That's an additional property that it's kind of hard to emphasize. So I just went through all of our markings that are really important pertaining to the parallelograms. Once again, if we're going down the chart, a parallelogram is sometimes a rectangle. It is sometimes a rhombus. It is sometimes a square. A rectangle is always a parallelogram. A rectangle is sometimes a square. A rectangle is sometimes a rhombus if that rhombus is a square. A rhombus is sometimes a square, but a square is always a rhombus. A square is always a rectangle. A square is always a parallelogram. So keeping that straight is a really tough thing. And so now I think that we're ready to go ahead and answer question number 5. So in question number 5, we want to determine if the statement is true or false. All squares are rectangles. That is true because every square has 4 right angles. And we know that rectangles have 4 right angles. So all rectangles are squares. This is false. This should be a sometimes situation. Sometimes rectangles are squares, but not every time. All rhombuses are squares. This is false and only sometimes true. Some rhombuses are squares, but as soon as that rhombus does not have a right angle, then it's not considered a square anymore. So that's considered false. All squares are rhombuses. This is true, and that's because all squares have congruent sides, 4 congruent sides. And that is the end of today's lesson. If you have any questions over anything I talked about today, please feel free to email me. Otherwise, I hope you have a wonderful day.